Okay, I think I'm recording now. And well, I'm going to summarize what I have done so far. You remember that we need to work with spaces. Then we need to work with the heating and cooling loads. By looking at the heating and cooling loads report, we have a lot of information. And this is what we are going to do for this final assignment. We are going to place spaces and heating and cooling loads. Then we have this option, which is the energy optimization. We can set location, we can create the energy model, but we are not going to work with this systems analysis. We are going to work with this optimize, okay? So when you click optimize here, you are immediately in at this website in Insight, okay? First, you have to create an account in Insight with your King State email. It's for free, we know that. But first you have to log in as a user. Look at this, this is me. You have to log in and then you will have access to all this information. So first we need to work with the settings. We have Imperial and we can analyze the cost or we can analyze the energy. In this course, we are analyzing energy. We are not talking about cost, but for sure that will be important in professional life, okay? Because all these measures that we can do to save energy, they come at a price, and we need to understand how much money we are spending in order to save energy in the future. And then you want to, this is important, sort the widgets by importance, because we have a lot of options, and there are like 20 or around 20 different improvements that we can make in our building. If we sort these improvements by importance, we can understand what we have to do. Okay, so first we will start working on the most important measures that we can make to improve the energy performance, and at the end we will work with the last in terms of importance or in terms of energy savings. So make sure that you can sort this by importance. Click yes, and you so now we can click here, and there you go. This is like a 3D view. I don't know. You can take pictures of this, but I don't recommend you. There's a first-person view, camera interactions, section analysis, measure, explode model. So in measures, we can select something, and we have, for example, the area in square feet. Okay, yeah, so is it useful? I know we have the Revit file, and it's much easier working with Revit in order to measure the area by selecting this. We do have the area of the roof somewhere. Yeah, it's 12,300. Okay. So I don't know. I wouldn't use this interface because it's not in settings, performance. Okay, click everything, and the full screen, we don't need that. So this is not great. As you can see, it's the model, it's the energy model, but well, here we have walls, roofs, windows. Yeah. So we have different elements, but it's not a great graphic, so I wouldn't use that. What we do have to use is all these. Okay, well, first we have to look at this, because this is the kBTU per square feet per year. This is the key performance indicator, or the value that we use to understand if this is a good building or not in terms of energy. I told you that if we visit the Passive House Institute, we have like some reference here, depending on where we are, where our location is. we are allowed to spend this yearly energy per square feet, and we have to divide the total energy by the square footage of the building, because then we can analyze, we can compare different buildings, because of course larger buildings will consume more energy. Okay, but if we want to analyze the quality of the construction, we have to divide this by the square footage of the building. 202, I think it's too much. Okay, I'm familiar with, we can always change the settings, and I'm familiar with metric units. So let me first analyze this in metric units, and then I'll let you know if this is, okay, 600. If we are working with passive house buildings, this number in kilowatt hours by square meter should be around 150. Okay, so this building is very far from being a passive house building. Why? Because a passive house building, we can't have all this glass area in a passive house building. But as I told you, there are more things to life than watts and energy performance. Okay, so, and people like curtain walls, natural light, and yeah, so we need always to balance the benefits that we have with the glass and the energy cost of this design option. Okay. So let's go back to inside. Yeah, but we are spending like 4 times as much energy as we should do with a passive house building. Is that an issue? Well, yes, it is. But on the other hand, we have other advantages by using all this glass. Okay. The benchmark comparison, Revit analyzed all these features. We have the operating schedule, the HVAC, the roof, the blood load efficiency, the lighting efficiency, the wall construction, walls, glasses, infiltration. Okay, so we have all these elements that affect, and finally we have the PV performance. We have all these factors. I don't know how many. 1, 2, 3, 4, 5, 6, 8. I think there are around 20 factors that affect the performance. We have ordered the widgets or the factors by importance. So the most important factor is the operating schedule. Now we have been working 24 hours, 7 days. Well, this is what I did on the energy settings, but we can change that. Okay, this building is not operating 24/7, so we can save energy by not operating the building over the night, for example. Then I have selected an HVAC system that it's not the most efficient. So by selecting another HVAC system, probably we can increase the efficiency. Then the roof, I don't know what the current setting is, but I can improve the quality of the roof. And then the plug load efficiency. So this is about the power. Okay, so I haven't decided this, but this is something that matters. Probably if you use efficient equipment, you can save a lot of energy, especially in public buildings like this. In single family houses, doesn't matter. But in public buildings with thousands of devices connected, we can save a lot. And then the same thing happens with lighting. Okay. So there are different options. I don't know what I selected on the energy settings, but that's why this is useful, because in the energy settings, there are a lot of things that are here, and probably, well, I don't know. So there are things that I'm not editing here, or well, we have overwhelming information here. Okay, so out of all these options, when we are analyzing the inside, Now we understand what the best option is. Okay, so I will show you an example. And then we can benchmark. Our building with the current settings consumes 202. Okay, they're keeping the shape of the building. We can decide, we can select different materials. We can select different but we're not changing the shape. And we are not changing the location of the building, and we are not changing the orientation of the building. Okay, so by doing this, if I select the worst options, I can spend 562. And if I select the best options with that shape, I can spend like 80. Okay, so this is my room for improvement from 202 until 80. And I can, if I click here, okay, so the triangle is the current setting. This is the worst thing that I can select, and this is the best. Okay, so if I set everything to the best scenario, so this is the option is 12 hours, 5 days a week. Well, but now we have to talk to our client. Are we using the building 12 hours, 5 days a week? Or are we using this 12 hours, 6 days a week? Or are we using this, well, this is what we selected in the Revit file. I don't remember what it was. Or are we using 24/7? Okay. Okay, so I talked to my client. Yeah, 6 days, it's fine. Maybe it's not the best option, but this is what our client wants. Okay, so this is our room for improvement. We selected this, and we can talk to the client. Okay, are you going to use the building 6 days or 5 days, or I don't know? I think in the energy settings, I wrote 7 days a week, 12 hours. Anyway. Here we have a room for improvement. And when we are done with this, we can close, and now we know that we are here. And the HVAC. With the HVAC, okay, we're here. It wasn't that bad. We can select a worst option, but the best one is this one. So if I select this one, yeah, I can select a high efficiency heat pump. Okay, so here I remember that I selected a heat pump, but I can select a better one. And with this option, I bring down the number by 10.08 kilowatt BTUs feet square per year. Okay, so that's useful because just by changing the HVAC system and selecting a high efficient one, I can bring down the number from 200 and something. I can subtract 10 kBTUs. Okay. So now we are here. I want to select, I was here, but now I have, yeah. And what about the roof? What did I do? I don't remember. Well, I think here there's very little room for improvement. Yeah, we can bring it down 1. Okay, can do that. And this is ARCH360. I don't remember our roof. Well, I selected that roof, but it wasn't ARCH360. So, well, ARCH380 would be even better, but well, it doesn't. ARCH360 is fine. I mean, if we make it ARCH380, probably we can bring down this, and in our beam option, we can make it even better. Okay, but that would be the best. Then we have the plug load efficiency. So for the plug load efficiency, I have selected this option. I don't know. Here it's 0.6 watt per square feet. Yes, so this is something that we can decide but that depends on the quality of the devices that we're using. I'm sure we're using PCs on this computer. If we were using Mac computers, we would be using less energy because Mac computers, they are useless when it comes to real software other than design, but they are more efficient. The hardware is better, I know, or usually the hardware, the Mac's hardware is better than this Dell hardware. So, and this, what's the power per square feet? Yeah, so this is something that it's up to us, and up to us and up to our client. So we can talk about this. Okay, what kind of equipment are you using? This equipment, okay. So try to find the best equipment that we have. We can do that in single family houses when we are looking for a fridge or a washing machine or whatever. There are energy efficiency. There's an energy scale. Okay, so we can always select the best one. I don't know in the American system, but in Europe, there's yep. In Europe, we have these kind of brands. I don't know. Do you have something like this in the United States?
I don't think we do.
Okay. Anyway, so the things are getting better. So when I started studying this, we had the A and the A plus. Then we have the A plus plus, and now they are working with the A plus plus plus, because well, these German guys are always improving the quality of washing machines and refrigerators and all that stuff.
A plus was enough, I guess.
A plus, yeah, but this A plus is out of date now. So now there are better things than A plus. I don't know. Anyway, if we look at this, the European manufacturers of electric devices, they are forced to provide us with this brand. Okay, so we know what we are buying. So we can talk to the client and we can say, okay, so you want an A plus. Yeah, but an A plus 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 would be better. Yeah, but how much does it cost? Okay, so that happens with computers, washing machines, dishwashers, anything. Okay, so I'm sure that in this Energy Star, there's another scale, but I'm not familiar with it. Okay, but I'm sure that you can find out. You can find out if the device that you're buying is the most efficient or not. Okay, so this is what we mean when we're talking about the plug load efficiency. Okay, so we have to make sure this is not up to the architect, it's up to the client or the building user, but it matters. And with lighting efficiency, it's the same. If we use this, again, here we have watt per square feet. We need to know the lighting efficiency. Okay, so here we have different options, and I'm sure you have the power that we have with incandescent or this, what is the name of that kind of light bulbs?
CFL.
CFL, but what does it stand for? We don't know.
Yeah.
Okay, the incandescent light bulbs were well, they are very inefficient because they emit a lot of heat. If you touch one of these light bulbs, you get burned because they are emitting a lot of heat. So that was another option, but now everybody's using the LED light bulbs. Okay, so we can find out lights. I don't know what the bajo consumo. I don't know the name. ARCH CFL. There are other factors like the mercury. Now mercury is something poisonous. Well, it was poisonous, but now they have found out that it affects the human health, and lead has no mercury as well. We have the average lifespan, and okay, so and this is 60 watts. Okay, so this is the heat that we are emitting with this incandescent light bulb. We are emitting 60 watts. With this one, we're emitting six. Okay, so it's, and in terms of light, there's another parameter that we need to look at. This is in terms of heat or in terms of energy consumption. And then we have in terms of the light that we are emitting. Okay, because we need these two, we need the energy consumption and we need the light. Anyway, so there are a lot of things to learn about this. This is not architecture, but we need to be aware that selecting the right equipment, it matters when it comes to calculate all this. And then the wall construction. Okay, so here, this is ARCH360. Okay, so they're not even, we can be more restrictive than this in this option. Okay. And then we have the northern window to wall ratio. Okay, so this is something that affects the building itself, the wall to window ratio. So in this case, I wouldn't change anything. So I would keep, this is our ratio, it's 21% in northern worlds. We can reduce that, but that means that we are changing the design, and I don't want to change the design. I would just to change the features that we are using. Window glass, I think we are using the best option. Okay, so there is no difference between this one and that one because we selected the triple glazing. Infiltration. We selected a tight building, so there is no room for improvement here. So this is what we selected. The southern glass, again, I think, yeah, so the best option here is triple glazing, low emissivity, but I think this is what we selected, so there's no difference between this one and that one. The building orientation, we are not using this because we can't change the building orientation. The window to wall ratio in southern worlds, we're not going to change. So we select always the beam option. The controls, daylighting and occupancy controls. Well, controls, and this building has controls, but well, I wouldn't use that. Then the eastern walls, yeah, but that affect very little. Okay, so we have changed the things that affect the most. We are bringing down the number. You remember that at the beginning was 202, now it's 106. Okay, so just by changing the operating schedule, if we can, by changing the most efficient heat pump, by changing better R value in the roof, and by reducing by increasing the efficiency of the equipment and the lighting, and then other options, as you can see, the wall construction, the northern walls, we are working with a high R value in all the walls. Okay, and then those last options are not relevant. And what about the PV? Well, as you can see here, we don't have the triangle. So this is because we haven't told the system that we're using a PV array. I wouldn't use this, so I wouldn't do anything with the PV payback or the PV array. I want to have this number, and then I need to produce this number with the PV array. This is what I would do, okay? So I wouldn't let Revit calculate anything about the PV array. So I will do it on my own. But this is what we have to do. Does it have to do with architecture? Well, the operating schedule doesn't have to do with the design. The HVAC system, it has to do with the design, that it's the mechanical system design. It's not the architecture, but it's very important because if we select the worst system, we are increasing. So we can have a perfect design from the architecture point of view, but if we have the less efficient equipment, we can end up spending a lot of energy. And then, yeah, so that's the equipment, the load efficiency or the lighting efficiency depends on the architectural design. It doesn't, but it matters. Okay, so we have to make sure that our clients or the building users are using the best equipment or the most efficient and the most efficient lighting that is available in the market. Okay, so with this one, we can build a new scenario. So I will rename this as improve TDS. Okay, and now I can compare the improved TDS with other things. So I have created that scenario. Probably I should create the first one, and this is the second one. Okay, so this is 106, and the other one, I didn't create the scenario before, but it was like 202. Or I can compare something. Okay, what if my HVAC equipment is the worst? I can add another one here. I can rename this with worst HVAC. Okay, so now I can compare this because that depends on the client. Okay, so you don't want to spend money upfront on a high efficient heat pump. Okay, so this is what you will end up consuming over a year, and this is what you can consume if you improve this. And now with this, we can make that calculation. We can compare the energy that we are saving, and if we are saving energy, we are saving money. And then we can compare the energy or the money we are saving operating this over 1 year, 2 years, 3 years, 10 years. And we can compare this with the energy that we will end up paying with this system that it's worse. But probably this is cheaper at the beginning. Okay, so here we can understand this. That's quite useful because just first by sorting this by importance, we can understand what the most important thing is. And well, this is something that we can't control the operating schedule because if the building has to work 24/7, it has to work 24/7. There's nothing we can do. But we can, yeah, so by changing the efficiency of the heating system or heating and cooling system, we can understand the difference between having this system or this one. If we know the price of this system and the price of this one, then, and we know the savings, well, we can advise our client about the upfront cost and the savings in, and then we need to understand how long we are going to use the building. The TDS building, I mean, it's meant to last for 50 or 100 years. We're not going to demolish this building in 5 years, I hope. Okay, so I think this is easy enough. We can understand easily what we have to do, and we can understand easily the impact of our measures. Okay, but first we have to design something good. There is no point on doing this, having single glazing, R value 10. Now we need to, we know what it takes, having a good building. But yeah, so there are factors that are not under our control, like the schedule or efficiency of the, and with this, at least we can understand how these factors impact the performance of the building. Okay, so that's it. We can model the building, and I think you should include this inside analysis. How can we do that? Well, first, you can run at least 2 different scenarios, the best one with all the best options. We can run 3 actually. So we can run the original one, which was 200 and something, then the best one, and then something in the middle. And then we can copy, and we can open our nice final report. Okay, and the last point would be 8 inside analysis. And I want the inside analysis 8.1, the first, without improvements. Second, we can improve just 2 widgets. And finally, we can have the best analysis. Okay. And what do we have to do here? We have the inside analysis, and we can copy this picture and place it here. I think it's better if we take a if we take that screenshot. But then you have to let me know what you have done here. Okay, so what does it mean, the worst HVAC system? The word HVAC system means that we are using this ARCH360 variable air volume, and the best one is the high efficient heat pump. Yes, so we can take this one. For the one with only three improvements, then we can take this, where is it here, with the best. There you go. And that one with the original one, which was the triangle. So this is it. So that would be the first one. Then we need to include some improvements here, and then this is the best analysis that we can get. Okay, and then we have to do this with the, not with all of the widgets, but here if we have improved 2 widgets, yeah, so we have to do this at least twice. Okay, so what this would be improving the HVAC equipment. Okay, the next one will be improving the lighting, and then here you have to copy and paste 3 options for improving the lighting. And here we have the total, the 3 scenarios. The first one, the scenario with 2 improvements, and then the best analysis that you can have. Okay, so that would be the final point. I have added this description of the building, the Revit model analysis of the PV array, the passive solar heat gains. These are the passive solar heat gains in a room with a lot of glass, so we can use either the creek space or the lobby, because this is where we have the highest amount of glass. And the PV watts daily analysis. This is what we have been doing over the last week. And the heating and load report analysis of the spaces that we are studying, at least 3 spaces. And finally, the inside analysis. And that will be the final report. We could add, we didn't have time to analyze this with therm, but we did it on the midterm. Yeah. So if you are analyzing a building and you're able to create a report like this, I think you can be considered an expert on building energy analysis. Okay, do you have any questions about this?
No.
Try to work with this, or try to work with this. First, we have to try to work with the energy settings. It doesn't matter, because when we are analyzing inside, we can compare different energy settings. But especially, so when you have to work with this advanced, so make sure that you are analyzing here. So probably we will have the high efficient heat pump somewhere. Yeah, one of the options would be that option of the, but at least make sure that, or realize what you are selecting. Realize that what kind of building operating schedule you are selecting, the type of building that you have. Make sure that you are working with spaces, okay? Because here we can work with rooms or spaces, but it's better if we work with spaces. And for the schematic types, here, this has to be building, okay? Because if we are using building, that means that the roof and the walls that you have designed on your on this model, you are taking that into account. You can save. Okay, so this is the options, the different options that Revit is analyzing then for roofs or for, and we have a lot of options here as well. Okay. But if you are not designing your specific roof, then you can select one of these options. So I don't recommend you do this. So just edit the type, select the roof, and edit type, and make sure that you can control the right option here, and that will be better. Okay, so we use these default Revit options when we are not designing the edit type that we want, but we know how to do it. So if you're analyzing energy settings, advanced, leave it as a building, and probably click detailed elements. Yeah. So click detailed elements, because by clicking this one, you will be getting the options that you have already edited here in the model. But remember that if you want to optimize this, first you need to create an energy model. I have already created one. If I want to create another one, I want to delete it. And now, if you don't have an energy model, if you click optimize, well, this is the thing that we have already done. So first you have to create a new energy model. It doesn't take that long. Okay, so you should have this. This is the energy model. And what it takes long is to generate this analytical model and the potential performance outcomes with insight. Okay, so if you click here, generate, that is what it takes a couple of hours. When you are doing this, using the energy analytical model, and well, it's working on it, and then you will receive an email, we are generating this report, and when it's done, you will receive another email. But if you are doing this and you click optimize, you'll see, yep, that there's analysis in progress. Okay, so this is not already done, and in a couple of hours you will be able to see this.